I think you can solve question 5. Change it to exponential form. Check your solution. So the base of the log is 2. The answer to the log was your exponent. And then you simply had a linear equation to solve. When you substitute 7/2 into the argument, you could see that 7 plus 1 is greater than 0. And so we have our solution, x equals 7/2. I'm going to suggest whenever you see ln, the natural logarithm, that you replace it with log base e. We did a question like this in the last video. Give this one a try. So the natural logarithm was replaced with log base e, and then you changed it to exponential form. Base e, the answer to a log is the exponent. E to the power of 8 equals e to the power of -2x. Our bases are the same. So we can say that the exponents are equal. Divide by -2. X is -4. That x is in our argument, right? Log base e is being applied to all of this. So we have to check our solution. E to the power of -2 times -4, that's e to the power of +8. That is greater than 0. We can keep this solution. Why don't you solve question 7? So some of you will have changed this to exponential form. You had a base of 6, and the answer to a log was the exponent. But some of you will have known this answer. 6 to what power equals 36? All of this equals 2. That would have taken you directly to 5x plus 3 equals 2. That's fine. Otherwise, you made your bases the same, and then your exponents were equal. We don't need to check this solution. Why is that? Because x is in the range part of the question, right? Log base a of x equals y. And our range for logarithms is the set of all real numbers. We can keep our solution. I know it's a little bit confusing because x is there, but x is just representing the unknown. It's not representing the y coordinate or the x coordinate. Why don't you try question 8? Did you get till here? And now you don't know what to do? You do know what to do. This is a quadratic equation that can't be factored. What do? Yes, we use the quadratic formula. You have that memorized, don't you? Why don't you go ahead and solve that? So when you substituted in the values here, oops, I forgot my plus or minus. You should have had this solution, x equals -1 plus or minus the root of 85 all over 2. Now we do need to check that solution because remember that x is inside the argument here. Well, I know that the square root of 85 is greater than 1. So I know for sure that -1 plus the root of 85 all over 2 is, when I square it, when I add it, it's going to be greater than 0. So all of this squared plus all of this The question is, what happens when I have -1 minus the root of 85? Well, first of all, I'm going to square it. So that makes it positive. And then I'm going to add -1 minus the root of 85 all over 2 plus 4. I need this to be greater than 0. Let's take a moment and think about that. We're not using calculators, so how do we do this if we encounter it on a test? My suggestion would be to estimate. We know that the square root of 85 is close to the square root of 81, which is 9. So let's think about it as 9. So we have -1 minus 9, -10 over 2 squared, plus -10 over 2 plus 4. This gives us 100 over 4 minus 10 over 2. Minus 10 over 2, I could say that that's 20 over 4 plus 4. I can see that this is greater than 0. So my solution for this question is -1 plus or minus the root of 2.